In this presentation, we're going to look at box plots and outliers. So suppose we are constructing a box plot for the data set in this data set here. Okay, we're drawing a little box plot for it. Now, we're not actually drawing the box plot in this presentation. What we are going to do is determine if there are any outliers for this box plot. Okay, so given that the first and third quartiles are 19.5 and 36 respectively, which of the observations will be depicted as outliers on the box plot? So first off, what do I mean by that? So you might actually have a box plot that looks something like this. Okay, a little bit strange looking, but you might have a few outliers on either side. Okay, and how do we detect these outliers? They're outside the fences. So what are the fences? Well, we have two fences. The lower fence, and that is computed as lower fence LF, let's say, equals Q1 minus 1.5 times IQR. Okay, and similarly the upper fence is UF, let's say, equals Q3, that's the third quartile, plus 1.5 times IQR. Okay, so they're very similar calculations. They both involve Q1 and Q3, but they also involve this term here, IQR. Now the IQR is simply IQR, simply the difference between the two, Q3 minus Q1. Okay, now for this data set we're actually told what they are. So the IQR is 36 minus 19.5. We were given those two values, and that is 16.5. Okay, and the necessarily 1.5 times the interquartile range. I just actually have it there. Is 20. Sorry, just slightly out of shot there. I was just practicing myself with this data. So it's 20. The 1.5 times. 1.5 times, a bit of calculator work, times IQR is 24.75. Okay. So, what is the lower fence? The lower fence is 19.5 minus 24.75. Okay, that's actually a negative number. So, what I'm going to do, it is minus 5.25. Okay. Let's just say, for argument's sake, that isn't meaningful in this data set. What you could actually do there is just actually replace it with 0. Okay, the lower fence is 0. Okay, now we don't actually draw the lower fence on our box plot. It's just to sort of determine where the if there's any outliers in the lower half of the data. Let's do the upper fence. The upper fence, let's keep it in blue. Upper fence equals Q3 plus 1.5 times IQR. Okay. Q3 was 36 plus 1.5 times 16.5. Okay, and that is 36 plus 24.75, and that is 60.75. So what we have to do is check the data set to see if there's any values less than 0. Now, just straight away, actually, I should sort of mention that there's no values less than the lower fence. Okay, but let's look at the upper fence. Okay, and are there any values greater than? Let's just check the number again. 60.75. Are there any values greater than 60.75? There's actually 2. Okay. So what's going to happen here in our data set, in our box plot, is that these two items will appear as outliers on our box plot. So it'll sort of look something like this. I'm not going to spend too much time sketching it, but it's so it'll look like this. Okay, so 67 and 70 will be out there. This is 36. That's where Q3 will be drawn, 19.5. Just not actually asked in this question, but where would you draw this? Okay, so it's the highest value, not considered an outlier. So this is going to be 54. So that would be point 54 is where you would draw that. This would be the lowest point that's not an outlier. That's 10. This is the in here you would draw the quartile, the third or the second, the median. What am I doing? Trying to get my pens sorted out. That would be 26 there. So that's our box plot drawn. But again, we were only asked which 2 points are outliers. So the stuff the comments I made there at the end were just sort of extra comments. Okay, that's it.